yesterday, we're moving up and right or down and right. You agree? Decay graphs then are going to go
Up that way.
down and right or up and right. Well, I should say that left and up or left and down. Those are the differences in the graphs themselves. Okay? It's very easy to tell which ones are going to be growth versus decay. Think of it this way. When you're looking at an XY coordinate grid, what two quadrants have negative X values?
The second and the third.
Second and the third, yeah. The ones on this side. So if this was your graph, notice how the X curve is going up this way and the other one can be going down that way. So it's got negative X values. Think of that as decay. X values are negative, for the most part. Go in the other direction, X values are positive because it's an increasing going from left to right. Does that make sense? Very easy way of denoting which one's which. You guys are looking at me like I'm really crazy. It really is that simple. Believe me, I'm not lying to you so far.
So far.
Okay? Now, we've already done this. What happens here for the difference between growth and decay is very simple. Growth, B is greater than 1. Decay, B is between 0 and 1. That's the difference. You can tell the difference between growth and decay by looking at the B value. Everything else is exactly the same. Yes, ma'am? What if B is negative? Well, B isn't going to be negative because B, when there's a negative in front of it, means the A value is negative. Remember when we had a problem like that yesterday where we had the negative out in front of the fraction? That meant the A value was negative, the B value wasn't. So if you have an A value that's negative with a B value that's fractional, it'll look like this. It'll be dropping down into the third quadrant if it's a non-shift. Does that make sense? Yes, ma'am. Correct. Yep, the A value is what makes it change its direction. Sir?
What's that O for the decay?
That is a 0. See, you're sitting so far away now.
It looked like an O.
Well, you were sitting up here. When you sat up here, in Ben's spot last semester, you never had a problem with your eyesight. Then you sat next to Kaylee, and now she's crying because you left her. We'll keep him back here. How's that knife treating in the back? I'll keep him here, all right? Don't leave your chair. Oh, are they?
I mean, you can look right there.
Oh, are they?
Yeah.
All right, your homework for this weekend, you have to watch the movie Rushmore.
We could start the semester with magic, right?
Rushmore.
We can watch it in
You've
class, so I'll make a rap about it
I
after.
think so.
Yeah, we can make a song. Yeah, we can make a song about it afterwards.
So let's look at an example. Let's jump right into some shift ones and go through the process of doing it. Yes, ma'am. Yeah, we can do that if you want. I like to still use the same ones because it works the same. You just have to work with the flipping the fraction and all that. And we did a little bit of that yesterday. Remember we had that 3 halves, the -2. We just flipped it and had it 4/9. You'll get used to it again real quick. So we're going to do the whole shebang of graphing this one out. 5 times the quantity 1/2 to the x, all plus 2, right? Again, when we set these things up, we identify A, H, and K. That way you know which way things are going to get shifted. What's your A value? 5. So my A value is 5. So knowing that the A value is positive, you could probably tell right away which of the two graphs it should look like. The going up and to the left? All right, I agree. What's my H value? 0. And the K value? 2. So to these problems, we know that there's not going to be any horizontal shift, but everything is going to be moved where? Up. How much? 2. So we plot our parent graph, AB to the x, and go through it. All right. So it's 5 times 1/2, -2. 5, 1/2, -1. 5, 1/2, 0. 5, 1/2, 1. And 5, 1/2 to the 2. Thank you. Let's get ahead of myself. Okay. Bless you. Now remember, when you have a fraction raised to a negative exponent, what do you do to said fraction? Flip it. What is the reciprocal of 1/2?
2.
What's 2 squared?
4.
What's 5 times 4?
20.
So this is at -2 and 20.
Oh, you can get higher.
Mad hacks.
What do you do?
Can you touch this thing? Do it, I dare you.
I dare you too.
Triple dog dare.
I double dog
You can do that
dare
easily.
you. I double dog.
He has to like, he can do that jump like 3 inches.
You probably do like a running start.
Double dog.
Anyway, next one is at 10, 5, 5 halves. I'm not giving into peer pressure.
Hey, you know that's good.
5 fourths.
Nah, you still got it.
Oh, block 10, not 5, 5.
Yeah, I'm scared. So at -1, obviously it's not going to be the cleanest of the graphs. Remember, the reason that this one is increasing so rapidly is because your A value is great. It's a larger value than what we work with. So that means the height at which things are increasing, or the rate at which they're increasing, is just great. So -1, we're at 10. 5, 2.5, 1 and change. And we still have a horizontal asymptote at 0. Okay? So to each of these points, what do we have to do then? And now where's your asymptote? Oh, shush. 2. And there's my new graph.
How do you know the asymptote?
It shifted up. Your original asymptote was at 0, so everything got moved up.
Pick on.
Because the original asymptote of all parent graphs are at 0. Okay? And yes, I got lazy on that one and just moved my graph.
You did that? I didn't even notice.
Yeah, I didn't want to see
I
that.
double dog dare you.
I did this, and I went with that.
No boy. I don't do that.
If only. If only you believe in magic. It's a horrible song. All right, do another one. You do this.
Funny.
Joking, I'm sorry. Don't hate me.
Can you explain as we're going?
No, I'm not going to explain.
I like to learn
Oh.
Since when? True.
since the second semester started.
Yeah.
New semester,
That's all like
Yeah.
first semester, that's
New
why I
semester,
started
new
doing
me.
one.
Wait, where do I do like the, like the, I'm gonna.
You can go ahead, you know how to tap touch the graph. Now in the lower right corner, you can hit the lower right corner, move it up, you just make the graph smaller. There you go. Perfect. It's like you know what you're doing.
Kind of.
I think you should be a teacher.
Thanks. didn't hear you.
I didn't hear what you said.
Leave her alone, she's doing fine.
Wow.
Maybe you guys do push-ups.
I think she's smiling at me, right? Oh, yeah, I guess.
I gotta finish right here.
Okay.
Oh, you're just messing with me. I'm joking. Remember, guys, sometimes it's easy to remind yourselves where your shift and everything is going to go. After you make your table of your parent function, underneath the bottom there, why not put what your H and K shift's going to look like? So you know that you're, yeah, on the bottom of that, just say X minus 2, and then below all the Y values, say Y plus 1. That way you know if I'm asking you to list your ordered pairs, which I've been known to do, you do that.
Alright. It's not okay.
I wasn't doing
Oh, okay. Wait, can I not do the graph? Because nobody else did the graph.
Why?
What do you mean nobody else did the graph?
Alright, fine, I'll do it.
You're the one that volunteered.
Shut up, John.
Oh, today's There's no horizontal aspect. There's no horizontal. Oh, that right horizontal aspect? Yeah, the horizontal aspect was left, right. But I think it's vertical. There's no vertical aspect.
It's one. Don't miss
Notice how your graph is going down. It's right. Actually, down it. It's all those Y values are smaller than your aspect. You wrote it down. What's your K down? K value. So your aspect is your graph is moving downward, so its Y value is smaller than that's smaller than your K value. You're sure up on the H value.
Bothers me so much.
Right, you shift the graph. Why should the variables?
You just wrote that. That's exactly right. You're arguing with yourself. Yes.
Okay.
I'm more confused about everything right now than ever. I'm going to walk away. Good conversation. Alright. So, ladies and gentlemen, obviously at this point, you guys probably already noticed that this is not all that difficult from yesterday. Do you agree?
Yeah.
One of the tricks that I hope that you might be able to pick up on when you're doing these is that when you're working with your generic form, this K value is your boundary. Is that right?
No, it's boundary, it's AR1.
That's why I have a degree in math.
You don't teach your kids how to.
So your K value is going to be your boundary for your range. Whether it is above or below the asymptote is dependent upon the A value. The A value will tell you if your range is Y is greater than K or Y is less than K. Now, which one goes for which scenario? If A is positive, what will it be?
Greater than.
Greater than. So if A is positive, it's bounded upward. If A is negative, it's less than. It's a nice thing to remember. Obviously, when you're plotting your points, if you graph it, you should pick up on that right away. But if I'm just asking you to look at an equation and tell me where your asymptote is, you should be able to do that also. I mean,
It's K, right? Is it K?
It is, because that's your shift out. Yes, ma'am. Domain will all, yeah, for exponential growth models, they're going to be all real. Yes, sir.
Is the value for your domain and the asymptote going to be the same? The horizontal asymptote?
Not for domain.
Not for, but for range, like.
Yeah, that's what we're getting at, yeah. Because that's what I'm saying with the K value, because that's your asymptote.
Yeah.
Does that make sense?
Yeah.
So if I ask you, what is your domain and range of the following?
Range all real.
Here.
Got that one.
If I ask you what your domain and range is off of that, you should be able to tell me without doing anything.
Domains are real, ranges, -7.
Domain's all real. We're all with that.
Percentages are real. Like, no matter
And
what.
now your range, where's it bounded?
-7.
That's it. Just picking up on that, then that's by looking at these little tricks within the functions. If you look at these little tricks within the functions, it can be able to do stuff quicker. All right? You're going to see a lot of this as we get into some of the modeling of growth and decay stuff with the practical problems, whether it's, principal interest, things like that, which will start up on Monday. You'll be able to pick out how fast something is increasing or how fast percentage something is decreasing just by looking at the model, by these little tricks. Okay? Let me give you some of these to work on for tonight. Give you guys a little bit of time to get started on them now. It's the same problem numbers, but the next section ahead. So it's the same problem numbers we did last night, but it's section 8.
So are we still like graphing like the same exact?
It's the same stuff. It's the exact same thing. These are decay. So, I wanted to try to get both of those done in one day, but then I realized that might be a little bit much. So,
Thank you.
I do. I have plenty of graph paper. Let me pause this so you
Wait,
can.
this is what we did yesterday. Oh, they did.